Okay, welcome to Level 1 Science Online with Henny van Vuren.
Okay, hi guys. Welcome to this lesson. We're just continuing with forces and acceleration. Now, previously we spoke about all the forces that are involved, and then we started to look at speed-time graphs, um, and then acceleration and explaining the motion within those graphs. And then today we need to move a little bit further into this. Okay, so thanks to everybody who was on the call. On the call, we talked about the kereru here, and we did all of those, and we basically called it a day when we got to this question here. So, let's have a quick look. Now, two horses are ridden by Danny and Sam. They're racing against each other. The speed time graph of their two horses is shown below. Speed time graph. Use the information in the graph to compare the speed and acceleration of Danny and Sam in the first 60 seconds. That is very important. So speed and acceleration. So when we look at 60 seconds, that is where it is. Now from that, can you read the speed of Sam, the red line? Yes, you can. Sam is doing 8 meters per second. Can you do the speed of Danny, the blue line? Absolutely. He's doing 7 meters a second. Okay, so that is quite simple. So we have that and we can simply read that. But our acceleration during the first 60 seconds, you need to consider the whole 60 seconds, not just the part that we can see on the graph. Because can you see Sam is accelerating really fast over here, Danny is accelerating slower, but the question goes all the way to that point there. So we've already talked about the speed there. So when we then look at the acceleration itself, we need to consider that we're talking about this in this sense, that we are looking at the 60-second mark. Okay. Now with that, we can then calculate the acceleration. And the acceleration is going to be, in Sam's case, 8 over 16. Because it's our change in speed over our change in time. And Danny is going to be 7 over 60. Okay, so you can see there that Sam had an acceleration of 8 over 16, and so that gave us 0.13 meters a second. Now, just by looking at these, you can see that both of these lines, which one is the steepest? Steepest means which one is the closest to the y. And the one that's the steepest is definitely Sam. So when you do your calculation, you will see that Sam is faster than Danny. And that is the truth. So Sam went at 0.13 meters a second, and Danny went at 0.12 meters a second, basically. Okay, so all of that we can read from the graph. Now, that is acceleration and speed. But we can also calculate distance, but only when distance is from a velocity speed, a velocity or a speed time graph, not from a distance time graph. Okay, so the distance somebody travels can be calculated from a velocity time graph. And the way that we do that is by calculating the area under the graph. So in this case, you can see that our graph runs basically up here, across and down. If we calculate the area under this, it'll give us the distance. So the first thing we calculate is this triangle. And trust me when I say that it's actually worth your while to sometimes color them in, just to help you to visualize them. Okay, so it's that triangle, it's this triangle, and then it's the white rectangle in the middle. Now, a triangle is always half the height times the width. The reason for that is that when you look at a triangle is half a rectangle. Because if that is a rectangle there, and you cut it in half, can you see that there's one triangle and there's another triangle? In other words, half of the rectangle's area will be the area of my triangle. So height times width, so that's height, that's width, and half of that is going to be my rectangle. Okay, that is something that you are expected to remember. Then a rectangle is simply height times width, because it's the whole thing. So in this case, we're going to go, if we do talk about this first rectangle here, it's going to be half times 8, which is half times 8 times 6. That's going to be the area of our first rectangle. Plus half times 8 times 4. Between 22 and 18, that's 4. But the height is still 8. Okay, so half times 8 times 4 is this area, and then 8 times 12, because 18 minus 6 is 12. And that's height times width. Alrighty, so that gives us 24 plus 16 plus 96, which gives us 136 meters. So let's have a look at some actual examples. So remember the kereru that was flying, the wood pigeon? So the wood pigeon, we can see that they give us the information in 16 seconds. Bird B traveled 121 meters. So from 0 all the way through to 16. How much further did bird A travel in the same time? So if you know that bird B was 121 and bird A traveled for the same 16 seconds, but he went faster, but even though he accelerated slower, how much further did bird A go? So the way that we can calculate is by getting the area under the graph. Okay, so there's our first triangle. See, there's our first triangle. Then next part is a rectangle, and then lastly is another triangle. So this gives us exactly all of these triangles and rectangles, their height is at 10. And then the only thing that you need to calculate is your change in time. So for this section here, it's going to be 4. But for this rectangle here, you can have 14 minus 4, which is going to be 10. And then this one is 16 minus 14, which gives us 2. And now that we have those numbers, we can calculate everything. Okay, so very easy. We are now calculating the distance and adding it together. So for my first, bird A traveled from 0 to 4 seconds. Then also, that's for my first one. Now looking at that first section, it was half times 4 times 10. So half, because it's a rectangle, times 4 times the height, which is 10. Okay. So half times 4 times 10 is the same as half times 4 is 2, and 2 times 10 is 20. There you go, 20. Section B is 4 to 14. So how many seconds is that? 14 minus 4 gives us 10. And if it's 10 high and 10 wide, we know that gives us 100 meters. And then section C is 14 to 16, and I just said that it's 2 seconds that it took there. So half times 2 is 1, and 1 times 10 is 10. So now we add them together, 100 plus 20 plus 10, and that gives us 130. But let's look at the question. The question was, how much further did the bird travel in the same time? So you have to write down. So bird A flew 8.5 meters further than bird B, because 130 minus 121.5, which they gave us in the question, equals 8.5 meters. Okay, that's a very simple and easy one to do. Now let's look at the harvester. Okay, so a harvester was working in a paddock. The speed time graph shows the journey of the harvester. Calculate the distance the harvester traveled in the first 200 seconds. Now look carefully at what they've given you. Where does our time run from? It runs from 0 all the way through to 400. What is our question? 200. So area under the graph for this one is very easy. If our speed was 7, that's our height, and our width is 200. So 7 times 200 is 1,400 meters. Okay, and bang, merit. How easy is that, guys? Okay, so the harvester traveled from 0 to 200 seconds. So 7 was the height, 200 was the width. That gives us 1,400 meters. Total distance, 1,400 meters. Very, very easy. Now, what happens when they give you something that is a little bit more complex? Okay, so this was in 2017, but what I'm referring to is when you have a combination like over here. Let me just change the color of this. If you have a combination and they wanted you to do this side as well, how do you calculate the area of that? Now, it's actually very easy. You just cut it so that you have a triangle and a rectangle. Because if you look carefully now, over here we have a triangle, and down here we have the rectangle. So if I can calculate that area there and I add it to this area here, I can tell you exactly how far the tractor went, or not the tractor, the harvester went in this. Okay, so you just break it into manageable chunks, and that's what I said about coloring it in. It makes it very clear and easy for the brain to understand. Is that a different green? Yes, at least it is a bit. Okay, so there we go. A rectangle and a triangle. Alright, so let's look at this excellence question. So question 1D, after 90 seconds, Sam and his horse had traveled 710 meters. So 90 seconds, they give us a time and they give us a distance for Sam. How much further had they traveled compared to Danny and her horse at the same stage of the race? So Danny's time is also going to be 90 seconds. So how much further? That's distance, so we have to do area under the graph. First things first is, where's 90? Right there. They've given us much more data than that, but 90 sits right there. And you can see where these two are. Now we have to calculate Danny the blue line. So let's break that into sections. Okay, so the first section you can see there is a triangle. The next section is a rectangle, easy peasy. And the last section is another rectangle plus the triangle on top. Okay, so those are the areas that you do, but over here you can actually use this as one giant rectangle that gives you one less calculation to do. So when we color, just for interest's sake, there's another rectangle, and a tiny triangle up there. Okay, so there's my first triangle that I have to calculate. There's my first rectangle, but we're not going to do that because we're going to combine them, because that is much easier to do than 4 calculations. You see, I'm turning that into a square. Does that make sense? So you don't have to do them individually. You can add things to make it a simpler shape. Now, if you look at the calculation over here, we're running from 0 to 7. So my first rectangle is going to be, it's got a height of 7, it's got a width of 20. So we know that is half times 7 times 20. That gives us 70. Next one is going to be still at 7. The whole thing is at 7, but it runs from 90 down to 20. So that is 70 for the base multiplied by 7. And I believe that's 1000. 7 times 7 is what? Oh, I can't remember now. 40. Never mind. We'll get there in a moment. And then lastly, this one from there to there is going to be 60 to 90, which is going to be 30. Okay. So, looking at the first one, we said half times 7, which is the height, and 20, which is the width. And then we have 20 to 90, which gives us, that gives us 70 meters. Next one. So, 90 minus 20 multiplied by 7 gives us 490. Yes, any 7 times 7 is 49. Sorry, my brain is dead. Then, last one is our top triangle there. So, half times height times width gives us half times 12 minus 7. See, it goes all the way up to 12, but it only extends down to 7. So it's only that area there. Okay, that gives us 5 multiplied by 90 minus 60. Okay, and that's 30. And that gives us a total of 75. So then you take 75, 490 plus 70, and the question was, how much further had they traveled in comparison to Danny? So then you add those three numbers together, you subtract Danny's and Sam's from each other to say who went the furthest. So the total distance was 635 travelled by Danny. So Sam and his horse had travelled 75 meters more than Danny after 90 seconds. Don't get caught out by not doing this last part. That is very important. Otherwise you won't get your E. Now, just for interest's sake, I want you to please pause the video and let's do the whole of Danny's trip. So we've got this triangle, this rectangle, this rectangle, this triangle, this rectangle, that triangle, and this rectangle. But before you start, let me just show you how to break it down and make it a simpler task for you. Okay, so firstly, there's one triangle we know. We know all of these, but how can we simplify this? We can make this a lot simpler by combining this whole area there into one rectangle. Can you see that? And combining the two above into one rectangle. So now we only have 1, 2, 3, 4, 5 calculations to make, which is a lot simpler than it would have been if we had to do all of that. That looks like a lot of work. This is manageable. Okay, so pause the video and then quickly do those calculations, please. Okay, welcome back. I hope that went well. Let's go through that together quick. So the first rectangle, the first triangle was half times area, that gives us 70 meters. So again, it is 7 multiplied by 20 divided by 2 because it's a triangle. Next one we're going to do is this whole rectangle. How high is it? It's still 7, and it's all the way from 180 down to 20. 180 down to 20. So 180 minus 20 is 160. 160 multiplied by 7. Okay, that gives us 1120. Now we're going to do this triangle. We start at 12, we go down to 7. So that area there is 5. And then this area here starts at 60, ends at 90, so that's 30. So it's going to be 5 times 30 is 150 divided by 2 gives us 75. Okay, you can see there. Now we're going to do this rectangle. It's still only 5 units high, but how wide is it? It is from 180 down to 90, so it's 90. wide. So 5 times 90 gives us 450. And then lastly is the small triangle over here, and that small triangle has got a height of, goes from 12 and then it stops at 13. But its width is 180 minus, that looks like 150, so that's 30. So that seems like it's half times 1, which is a half, times 30, which gives us 15. And now we add them all together. So the total distance that Danny went was 1,730. And that's how you calculate the area under a graph. I really hope this helps. There's a summary of the different motions, which I've shown you already. So can I ask you just to complete those 3 pages for me in Education Perfect. No, not in Education Perfect, in the side pattern that is on the OLE. Okay, thank you guys. I hope you're keeping safe. Please look after yourselves. Thanks. Bye.